Hello, everybody. I will demonstrate how a specimen data curation pipeline is set up by using the Kepler workflow technology in the filter-to-push network. Firstly, let's see what the filter-to-push network is. It was proposed by the filter-to-push project. The filter-to-push project aims to improve the quality of natural science collections data. It builds up a filter-to-push network through which multiple collection data sources like GBIF, Specify, MorphBank, etc. are available to different users. Most importantly, it enables the data consumers to push their assertions about the data quality back to curators of the original distributed datasets and other interested parties. Accordingly, the collection manager can choose to either accept or reject the assertions. To do data quality control, any user of the filter-to-push network can launch a curation process. I will demonstrate how such data curation processes can be automated and simplified by building curation pipelines with actors from the curation package of the Kepler workflow system. This is a specimen dataset queried from the filter-to-push network. It's about vascular plants, and it has some quality issues. But before we set up a curation pipeline to clean it, let's start with a workflow to identify quality issues in this dataset. This is a simple workflow with just two actors. The collection reader actor imports the data from the spreadsheet into the workflow, while the visualization actor helps us to find out the quality issues by using the Google Maps service. Let's run the workflow to see what happens. Here we can see the distribution of each record in this dataset. Firstly, the point in the C is suspicious, because we know the dataset is about plants on land. By double-clicking it, we can see the detailed information of the specimen records collected at this point. The record was actually collected at Colorado, so definitely this record has a georeference error. Now, I'm interested in a specific species. Let's find the relevant records. We can also see the expected distribution areas of each species according to the authoritative data from Flora of North America. By checking the distribution of this species, we can easily find out that this point is a species distribution outlier. This record is collected in California instead of Colorado, so it can also be a georeference error. I know this dataset contains records from a trip of Mark Evan to California in May 1990. Surprisingly, we get a point in Hawaii, and it was collected on May 16. But all records here in California were collected very close to this time. It's highly suspicious, and most likely is a collecting event outlier. The geographical information of this record seems correct, so it might be an error with the collecting time. Since such an error is hard to be corrected automatically, we'll introduce human curation. We can check the validity of flowering time according to the authoritative data from Flora of North America. It shows that one record has an invalid flowering time, and we can see the expected flowering time here. We can also check the validity of the scientific name by using a service from IBNI. For a vascular specimen record, if its scientific name cannot be found in IBNI, then it must be wrong. We can see that this record has such an error. Until now, we found 4 kinds of errors that might exist inside this dataset. There are georeference errors, scientific name errors, flowering time errors, and collecting event outlier errors. Now, let's build up a curation pipeline to correct these problems. This is the curation workflow we built to clean this dataset. Between the collection reader and the visualization actor, we introduce multiple curation operations to correct the errors we found. The geolocate actor gets the latitude and the longitude for each record by querying the geolocate service with locality information. If it finds that the latitude and the longitude returned from geolocate is quite different from what is present in the record, then it will correct the error in the cleaned output record. It will also insert a curation comment for the record to let the users or downstream actors know what happened here. The scientific name validator actor finds out whether the scientific name of the input record is wrong by searching for the scientific name and author in the IPNI. If no record is found in IPNI, then the actor will continue searching in Global Naming Index. If there is a record from IPNI in the returned lexical group, then the name of this record will be used as a replacement in the cleaned output record. For each output record with a scientific name existing in IPNI, the IPNI LSID will be added to. The flowering time validator actor tries to find out whether the flowering time of the input record is wrong by using the authoritative data from Flora of North America. In the cleaned output record, it will correct the error if there is one and insert the curation comment accordingly. The collecting event outlier finder actor reads in all the records and tries to identify outliers by using clustering methods. A potential outlier is identified using the local dataset. To further confirm that it is an outlier, the actor will get more evidence by querying the filtered push network for the data collected within 1 day before and 1 day after the date when the potential outlier was collected. The blinking arrow and the logo of the filtered push project indicate that this actor accesses the filtered push network. Actually, all actors with such markers are able to access the filtered push network. By doing so, they can query for relevant data or even the answers to the quality issues. Furthermore, they can inject annotations about quality issues to notify the collection manager of the original dataset or the other interested parties. Additionally, they can publish a workflow execution trace for evaluation of the workflow itself. To save time, instead of demonstrating all the possibilities, I only show the communication with the filtered push network and the collecting event outlier finder actor and the annotation inserter actor. Based on the functions I show here, you can imagine how the filtered push network can help curation in different ways. After a collecting event outlier is identified, it's sent out for human curation. The human curation actor is actually a sub-workflow. After opening it, we can see that it contains multiple actors, and it also has multiple nesting layers. Such an encapsulation capability makes it easy to reuse the sub-workflow, and it also provides a view of the workflow at proper granularity. This actor contains one actor to dispatch the curation to the proper curator, and another actor to collect curated data from a curator. The dispatcher actor also contains a sub-workflow. Basically, it chooses a curator according to the domain of the data to be curated, by querying a spreadsheet that stores the curator information. And then it imports the data that is to be curated into a Google spreadsheet, shares the spreadsheet with the curator, and finally sends an email and a text message to the curator to inform the incoming curation request. The curation collecting actor posts the status of the spreadsheet until the curation is submitted by the curator. Then it collects the human curation result and sends it back to the workflow. Finally, the curation summary synthesizer actor collects the curation information, compiles a summary report, and imports it into a Google spreadsheet. Then the actor will send an email to the user who runs this curation pipeline to communicate that the curation process has been finished and the summary report is ready for review. Besides the curation summary report, the curation summary actor also generates annotations on data according to the quality issues found in this dataset. The annotations will be injected into filtered push network by annotation inserter actor. Let's run the whole workflow to see what happens now. After multiple automatic curation steps, the identified collecting event outlier together with the other evident data will be sent out for human curation, and the workflow is suspended here, waiting for the response from the curator. Let's enter the mailbox as the curator to process the curation request. A notification mail is coming. A text message is also coming. By following the link in the email or the text message, we reach the spreadsheet that contains the data to be curated. we can see the outlier record and all comparator records against which the outlier is identified. The local comparator records come from the dataset itself. The remote comparator records are queried from filtered push network as further evidence. By going through these records and investigating the other materials, we find out that the collecting year is wrong. Let's correct it, confirm the record has been cleaned. Write down the curation comment, and submit the curated record. Here, after curation, we get the dataset again. Let's see what has changed. The record, which appeared in the sea previously, now locates in Colorado correctly. After searching for this species again, we can see that the record is not an outlier of species distribution anymore. The georeference errors of these two records have been corrected through the geolocate service. We can also see that the flowering time and the scientific name errors have also been corrected. How about the collecting event outlier error now? By searching for the trip of Mark Alvin during May 1990, we can see the collecting event in Hawaii is gone. If we search for all the data of Mark Alvin, we can see that the collecting year of the record in Hawaii was changed to the correct year. When the curation is finished, the user running this curation pipeline will receive an email containing a link to the curation summary report. To save time, the email is also sent to the filteredpush.nsf mailbox. By following the link, we come to the curation summary report spreadsheet. The first worksheet contains the original to-be-cleaned records. The second worksheet contains the final cleaned records. The other worksheet contains the detailed information of each curation step. On the geolocate worksheet, we can see that 2 records have been corrected. For each of them, we can see the original record, the cleaned record, the comment about how and why it was cleaned. The field in the original record that should be corrected is also highlighted. In the collecting event outlier worksheet, we can see the outlier and the records against which the outlier is computed. And we can also see the comment or curation from both the automatic curation step and the human curator. Now, let's open the Filtered Push web client to see how the people in the Filtered Push network get notified once their interested data has been identified with quality issues. We log in as Jeff, who is interested in the data from the Consortium of California Herbaria. He can register his interest in this preference page. In the inbox, he got 4 messages about the newly inserted data annotations. But why does Jeff, who is interested in data of the Consortium of California Herbaria, get annotations for data from Davis? Actually, this is because the data from Davis has 1 duplicate from the Consortium of California Herbaria. By going to the detailed page, we can find the information of duplicates. When the annotation about the data from Davis is injected, the Filtered Push network will send out messages to all its pre-discovered duplicates, since they might also be affected by this annotation. Coming back to the workflow, in addition to executing functions, the Kepler workflow system also records the workflow execution trace completely. This information is very helpful to trace the data provenance and assess the credibility of assembled, curated data. The collection display actor shows the trace in this window, and the trace writer actor writes it into a trace file. By opening the trace file in the provenance browser, we can clearly see the data lineage by following the data dependency indicated by the red line. Provenance browser also enables provenance query, which is very useful when handling complex provenance graph. This is the specimen curation workflow I want to show. Thanks for watching.